Today we are going to learn one more chapters from class 10 maths. It is chapter number 5, no? Arithmetic progression actually. So what do you mean by this arithmetic progression? In general term, arithmetic means the mathematical numbers and the progression means the moving from one number to another, isn't it? So in general terms, if I say the arithmetic progression means it's a sequence of some numbers where we can move from one number to another, is it? So this is in general term. But if we see the definition, mathematical definition of arithmetic progression, it is the sequence of number where the difference between two consecutive number is constant, isn't it? So it is a sequence of number where the difference between two consecutive number is constant. So again, what do you mean by sequence? Sequence is nothing but it is orderly arrangement of some numbers, is it? So orderly arrangement of some numbers. So as a whole, it is a sequence of numbers where the difference between two consecutive number is constant. So let's try to understand this particular concept by taking some examples. Okay, I have already written some examples. So this is, as you can see, the sequence of the natural numbers starting from 1 to 100. Okay, and this is the sequence of odd numbers, as you can see, and if you can recall, this is the sequence of the prime numbers 2, 3, 5, 7 prime numbers. As you know, the number which have only two factors, 1 and the number itself, isn't it? So we have taken the examples of 3. So if you see in this particular case, the difference between the first and the second one, two consecutive, what is the difference? The difference between these two is, see, 1. Again, if we see the difference between the second and third is again C 1. If we see the difference between this one and this one is again C this 1. When I say the difference, see, subtracting this one from this one, this is also the difference, and subtracting this one from this one means subtracting this one from this one, this is also difference. But always remember, in arithmetic progression, for calculation purpose, we always consider the difference is the subtracting the predecessor number from the successor. Means the difference, how we can get the difference means from the successor 2 minus 1 is equal to 1. So this is the difference, this is how we can find the difference. Okay, so again, how we can find the difference between these two numbers, suppose 3 and 4, how we can find the successor number is 3, predecessor number is 3, successor number is 4, 4 minus 3, that is 1. So in this case, if we see the difference between two numbers is like this. In this particular case, if we see the difference between the first and the second, 3 minus 1, 2. In this case, see, 5 minus 3, again 2. In this case, if we see 7 minus 5 is again 2. So in this case also, the difference between two consecutive number is constant, isn't it? Now, in this case, if we see the difference between these two numbers, 3 minus 2 is equal to 1. The difference between these two numbers, 5 minus 3 is 2. In this case, the difference between these two numbers is again 5 minus 7 is again 2. And in this case, it is 4. So, if we see in this particular case, the difference between 2 is constant. In this case also, the difference between two consecutive number is constant. But in this case, the difference between two consecutive number is not constant. See, in this case 1, this is in case 2, 2, 4. So this particular arrangement of numbers, and this particular arrangement is called arithmetic progression. Means these two arrangements are in arithmetic progression, but this particular arrangement is not in arithmetic progression. Okay, understood? This is how actually we can verify whether the given sequence of number is in arithmetic progression or not. If suppose the difference between two consecutive number is constant, then it is in arithmetic progression, and if that difference is not a constant one, then it is not in arithmetic progression. So up to this, any confusion, I hope you understand the concept, basic concept this is. Let's move to some other concept suppose. So second important point is the type. There are two types actually, the finite and infinite one. Let's see from the examples. In this case you see this AP have the initial number and the final number. The initial, it starts with 1 and it ends at 100. So initial and final numbers are there. But in this particular case C, initial number is there, but there is no final numbers. Means this particular sequence of numbers, it goes on and on and on. So this is finite one and this is infinite, because this particular sequence, it goes infinitely and this is finite. So on the basis of whether the given sequence of number is a finite or infinite one, there are two types, the finite AP and infinite AP. Okay? Okay. Now let's move to some other concepts which are related to AP. Again, let's take one simple AP, the sequence of odd numbers start from 1. So in this particular case, if we see, so these are called terms. Okay, these are called terms. So since this is the first one, so this is called the first term, and we write the first term as A1. A1. Similarly, the second term A2, third term A3, fourth term A4, like this. Okay. This number represents the number of terms. Means the first one. This is the second one. This is the third term. And this is means the fourth one. And as we have seen, since it is in AP, we have seen the difference between the first two numbers. 3 minus 1 is 2. We have seen the difference is this one. This is the difference. Okay. Now see, if we see the sequence, how we can get the second term from the first term? Is there any relationship we can find between the first and the second term? Or can we find any relationship between the second term and the third term? See, if we add the difference along with the first term, we are getting the second term. Yes? See, the first term, this is first term, means if we add the difference, means first term is 1, if we add the difference is 2, if we add the difference, we are getting 3. Means along with the first term, if we add the difference, we are getting the second term. Means first term we are representing by A1. This is what the difference. We are getting the second term. See? Similarly, how we can get the third term? Along with the, see, how we can get the third term? Along with the second term 3, if we add 2, means 3 plus 2 is equal to 5. Yes, 3 plus 2 is equal to 5. So along with the second term, if we add the difference, we will get the third term. Means along with the second term, if we add the difference, we will get the third term. Yes. Now see, A2 means A1 plus B. So if we replace this one, A1 plus B. If we replace this A2 by this one, D, A1 plus 2D. So A3 means A1 plus 2D. So this way also we can express. This is one presentation and this is another representation of the third term. Yes. Similarly, the fourth term, how we can write? The first term plus see the fourth term, how we can get the fourth term? Adding the difference along with the third term, adding the difference along with the third term. So third term we can write like this. So this is the representation of the fourth term in terms of first term and the D. So if we write the arrangement in terms of A and D, so how it will be? The sequence of numbers will be like A1, A2, A3, A4 like this, isn't it? So the first number A1, we can write first number as A. Okay, A1 or A, it is same. So we can write the first number as A also. Second term, you see, second term A2. How we can write the second term? A1 plus D. Or A1 in place of A1, we can write A plus D. Okay. Then see third term A2 plus D. A2 means A2 plus D. So this third term we can write in this format also. A1 plus 2D. A1 means A plus 2D. Similarly, A plus 3D, like this. So, expressing this sequence, any sequence arithmetic which is in arithmetic progression, so expressing the sequence in this format, this is called as general term of arithmetic progression. So, general term, it is called as general term also. General term of AP. Okay, so general term of AP. So this particular expression of the sequence of numbers is called as general term of AP, where A is the first term and D is difference, common difference. And as I have already told you, how to find the D? See, from here also you can, from here also, this is A1 plus D is equal to A2. So how to get the D? D A2 minus A1. From here see how to get the D. A3 minus A2 D. A3 minus A2. Okay. Even from here also, how to get D? A4 minus A3. So this is how mathematically we can find the D, that is the common difference. Means subtracting the predecessor from the successor number. Subtracting the predecessor from successor. So in this case, you see how we can find the D. Suppose in this case, 3 minus 2. This is the successor number, this is the predecessor number. So to get the 3, that is the A2. A2 is this one. A1 is this one. So 3 minus 1 is equal to 2. This is how we can find the D. Even in this case also, third term minus second term. Third term minus second term is equal to D. 5 minus 3 is equal to 2. So this is how we can find the D. And the first term of the given sequence, it is the first term only. It is very easy to find the first term because the first number of the sequence is the first term. Okay? So this is how we can write the general term of an AP. Now, there is another important point in this particular case. Suppose this is a infinite AP, but if we consider this particular AP as a finite one, suppose we are considering the sequence of odd numbers from 1 to 50. Okay, 1 to 50 means 50 is not an odd number, so obviously the last number will be 49. Okay, so this is last number of this particular sequence. So this last term, since this is the first term 1, this is the second term, this is the third term, this is the fourth term. Fourth term is this one. And this is this term, we don't know the number of terms. Okay, so we can write this one as the number of terms is an. Here n is what? The number of terms. Here the 4. 4 is what? The fourth number. Fourth number is 7. In this case, this particular number we don't know. So an is the last number. So generally the last number we write as a L. So what is L actually? So how to get this L? If we see this one, how to get the fourth number? Fourth number means to get the fourth number along with the first number, just one less 4. You have to multiply 3 along with the difference. What is the relationship between this one and this one? See, this one is 1 less than the number of terms. 1 less. So if we have to find the last, that is n term, then we have to take, if suppose this is the nth term, then an will be first term plus, we have to multiply the difference with whom? 1 less than this one. Here this is n. So 1 less means n minus 1. So along with the first term, the last term, 1 less the last term along with the d. So this is how actually we can find the nth term nth term. This is called the nth term. Nth term. Okay, so in this particular case, if we have to find the nth term, suppose this is the nth term, how we can find the nth term? A plus B. See, one less. 4 means A4, one less of this number, that is 3, one less, n minus 1, D. So this is how in a finite sequence we can find the entire sequence like this way actually. Okay, so this particular formula actually, where a plus n minus 1 d, if we see this one, a, where a is the first number, d is the common difference. What is n? N is the number of terms. And nth term. So this is how actually we can find the nth term. So ultimately, an a plus n minus 1 d. So this is how actually we can find the nth term by using this formula. Okay, so if we practice the question from the exercise, this concept will be more clear. But before going to the exercise, just I want to give you one small examples how to get the nth term. Suppose 1, 3, 5, 7 of this particular sequence, we have to find the 20th term. 20th term. Find 20th term of this sequence. So first we know an is equal to how much? A plus n minus 1d. Isn't it? So 20th means the n is 20. Means we have to find the term where n is equal to 20. Isn't it? So we have to find this one. So by using this formula, a is equal to how much? A is equal to first term, that is 1. What is d? D is 3 minus 1, that is 2. Yes? What is n? N is equal to 20. So how to find the 20th term? Means A20. We have to find this A20. A plus 20 minus 1. Because see, n is 20, 20 minus 1 into d. Here first term is equal to 1 plus 20 minus 1 is 19 into d is how much? D is 2. So 1 plus 39. So the 20th term of this particular AP is 39. So this is how actually we can apply or use this particular formula to find the nth term. Okay, so in this video we just want to wind up here only. So in our next video we will try to discuss the questions from the exercise, the first one. Okay, so till then, goodbye, stay fit.